Hi, students. Let's look at this question here, which is on functions taken from the year 2016 paper on question 10. So the function f is given by f x 1 plus root x for the domain x at least 0. Find f inverse x. Okay, great. So we just want to find the rule here. So we just let y equals to 1 plus root x. To find the inverse function, just need to make x a subject. So y minus 1 is equals to root x, and we have x equals to y minus 1 square, right? So this case, once done, we know that f inverse x would just be, we just flip the y back to x, so this is x minus 1 squared. Okay, now to find the domain of f inverse, we just need to sketch the curve. The curve is at least 0, so you may want to put the domain in, so that 1 plus root x, we could just put divide, then we just put x at least 0. Okay, but if you don't put it in this case, it's fine also. So the graph that we're looking at is such a graph. So the domain of f inverse will be the range of f. That's why we need to sort of like see what's the graph. So the graph looks something like that. Okay, so this is fx. So this is not part of the solution, so don't worry. So this is the range of f. Okay, so the domain of f inverse is equals to the range of f, which means that this is like at least 1 to infinity. Okay, so that's how you do the first part. I think it's pretty okay. Then we're going to look at part 2. Show that if fx equals to x, then this will happen. So this guy here will be fine. So I think for part 2, we are given this to start with. Okay. So what I'm going to do is actually just, we could f inverse both sides. Okay, maybe I could just, let me see first. Okay, what I could do is I could just f inverse both sides if I want to. Okay, so this is f inverse both sides. Now remember, if you f inverse both sides, this will nullify. It's just like in secondary school when you have sine x equals to y, we write this as x equals to sine inverse y. What happens here is actually we sine inverse both sides. Okay, so when you sine inverse both sides, the sine and the sine inverse would just nullify, and it will just get back x. So this similar, these two would just nullify it, and I'll get back fx. Now the reason why I'm doing this because I'm a bit too lazy to expand it, so I just let my fx be 1 plus root x. Then my f inverse x, I'll just let it be what we found just now, which is x minus 1 square. Right? I think it's pretty okay. So then, yeah, I'm just gonna expand this. So x square minus 2x plus 1 plus root x. So that is root x equals to x square minus 2x. Then square both sides. Should be fine. Should be x4 minus 4x cubed plus 4x squared. So I could just divide everything by x, and we'll get 1 equals to x3 minus 4x squared plus 4x. Okay, so that's about it. So then this will be 0 equals to x cubed minus 4x squared plus 4x minus 1. Okay, this is method 1, of course. Maybe I'll just write this as method 1. I think the normal method would then be you just replace it in. So method 2 is just a conventional way. So we're just gonna replace everything in. So it's f 1 plus root x equals to x. Then we're gonna replace this into the function again, 1 plus root x. Okay, then we're just gonna slowly expand. Root 1 plus root x, x minus 1 plus root x square. That will be, I think it's the same, you yield the same thing. Then 1 plus root x. Then this case root x is equals to x squared minus 2x squared again. Okay, then that will be x4 minus 4x cubed plus 4x squared divided by x both sides. 4x squared plus 4x. So minus 4x squared plus 4x minus 1 equals to 0. Okay, slightly different, but I think method 1, I just straight up answering the second part, which is I explained, hence find the value of x for which f inverse f x equals to x. Explain why this value satisfy the equation, okay? So if you want to find this solution, just use GC and find it. Because they didn't ask for exact value, so we could just find it. So you go to calculator math, go to apps, then we go to poly simultaneous equation, polynomial root finder, then we go to degree of free. Then we'll key in the coefficients here, 1 and negative 4 minus 1. Okay, so there you go. This is the value here. X equals to 1, 0.38196, 1, 2.618. So this case here, we have 3 values. We need to reject 2, I believe, because they ask us to find the value of x, right? So that's the problem there. But this is FF. It means a range. The range, because this would be range of FF is equal to x, right? So we need to find an x value which satisfy the range of the composite function FF. So for the range of FF, I would suggest using the mapping function. What we need is, so the range of FF, to find the range of FF, we need a domain, we need the range of the first function, which is f, sub into the domain of FF, then decide what is the resultant range, right? So we just use a mapping function. So from 1 to infinity, this is the range of f. Then I'll just sub into from 1 to infinity here. So this case here, I will have this range here, okay? So I substitute 1 into the original x equation. 1 plus basically f1, 1 plus root 1, which is 2. So this guy is 2, all right? So essentially, this will be a resultant range of FF. So this is the range of FF, inclusive of 2 towards infinity, right? So what we need to do is understand that x is a reject. We need to reject 1, and so reject this 2. Reject as the range of FF is 2 to infinity. So hence, x is equals to 2.62 as f. Okay, yeah, because f(x) equals to x, this is a range. This should be a set of the range of ff. Okay, so explain why this value of x satisfy this equation. I think this is pretty. I show in this method here. So since f(x) equals to x will mean that if you f inverse both sides, remember that when we f inverse both sides, what happens is this will be nullified. Okay, so this will be like just so this fx equals to f inverse x. Okay, so that's it. Okay, so that's how you show you satisfy the both the equation there. So let's look at part B. I think part B is the one which a lot of students have problem with. So for this second part, what I'll suggest is we just try and make sense of what's going on. This is the piecewise function, domain of set of non-negative integers. What is the domain of set of non-negative integers? Meaning to say the n, in this case the n here, n is non-negative, so it'll be 0, 1, 2, 3, 4. These are all integer values, right? Okay, so it is given by this function g here. So I'm gonna just try and plot the graph and try to understand what's going on. So from here, I like to start by looking at this n equals 0. So n equals 0, g0 is 1. Okay, so essentially it just means that if I were to plot this graph, g0 is 1 over here. So this is 1. Great. Then after which I move on to the next one. Because I'm trying to make sense, I don't really like to just jump in. So now we have g1. So we need to think about g1. Maybe I write this elsewhere. So g1 obviously is odd, right? So if g1 is odd, we are using this for n odd, we get 1 plus gn minus 1. So this is equals to 1 plus g1 minus 1, which is actually just 0. So it's 1 plus g0. g0 is 1, so it's 1 plus 1 equals to 2. So g1 over here is 2. Okay, I'm just roughly, then I need to find 2. So I just continue iterating here. G2, now 2 is an even number. So if 2 is an even number, we need to use 2 plus Gn over 2. So this 2 plus Gn, which is 2 over 2, which is G1, 2 plus G1, which is happens to be 2. G1 is 2, right? So G1 is 2. So this case here, it gives us 4. So G2 is 4 here. Okay. So the graph looks something like that. Okay, great. So now we move on to, also this is 4. Sorry, this is 4. Okay, then you can just continue iterating. So G3, this is odd. So this is 1 odd. We will use 1 plus G3 minus 1 with G2. So it's 1 plus G2. G2 happens to be 4. So it's 1 plus 4, which is 5. See? G3 is 5. Okay, so you just continue plotting them. So G4 is what we want to find, right? G4 is even. So G4 would then be 2 plus G, half of 4, which is 2 plus G2. G2 happens to be 4 also. So this will be 6. So G4 is 6. Okay. There you go. So we want to find G4. So G7 and G12. So I could just go to G7 first, or if not, I could just try G5. So G5 could quickly give me this G4. So that will be 1 plus 6, which is 7. So we quickly do it. I'll also quickly do G6. G6 will be 2 plus G3. G6 I worked out to be 7. Also here. Okay. Then of course we need G7. G7 is actually just G odd, which is 1 plus G7 minus 1, which is 6. Which is 8. Okay, so this guy will be 8 here. Okay, great. This is the graph that I'm looking at. So basically now we have G4, which is 6. We need G4, which is 6. G7, which is 8. And G12. We need G12. Okay, G12. G12 is even, so G12 would be 2 plus G6. 9. Okay, so that's it. So we done part 1. So does G have an inverse? Justify answer. So to see this G have an inverse, if you draw a horizontal line test, you know that this cuts the function twice, right? So then essentially G is not a 1-1 function, thus it doesn't have an inverse. So your right is actually since G5 equals to G6, which is 7. Okay. Okay, so basically G5 equals to G6 equals to 7 just means that when you draw a horizontal line y equals to 7, it cuts the horizontal line y equals to 7 cuts G more than once. So the horizontal line y equals to 7 cut G more than once, hence G is not 1, thus the inverse does not exist. So that's how we do this question here proficiently. If you have any questions at all, please do let us know and I'll see you in the next question.